Good day everyone, my name is Chong Mun Zheng from UTHM. Now I am going to present my final year project, which is about banana leaf disease detection using convolution neural network algorithm. First of all, why banana? Because banana is one of the most important fruits and also one of the most popular fruits in the world. However, the production of the banana has been declined sharply due to the diseases, so the banana quality has been reduced. Besides, it also brings huge impacts, like huge economic losses to the farmer and also hinder the banana industry development. To detect the diseases, there was a traditional method which was time-consuming, laborious, expensive, and inaccurate. Therefore, there is a better solution for that. We can detect the disease based on image processing by using the AI deep learning technologies. After that, what is the proper statement of the project? It is about the banana plant disease, as it brings huge concern for the farmers and it will lead to a banana epidemic in the farm. Therefore, it will reduce the banana production and quality. However, it only is detectable by experienced farmers only because it is hard to detect and classify. Next, the objectives of the projects are to detect banana plant disease through banana leaf using the CNN algorithm, to develop an Android application to help the farmers to detect banana leaf diseases early, and to evaluate the performance and precision of the disease detection model. Then the project scope are the banana leaf disease detection system is based on CNN algorithm. It only detects based on the colors and spot patterns. The database for the models are obtained from the Harvard Dataverse, and the diseases detected are black cigarra and fusarium wilt, as shown in the pictures. There are 3,000 datasets for healthy, black cigarra and fusarium for each class, used for training, validating, and testing. The models are developed in Jupyter Notebook, and the evaluation are based on the accuracy and the loss of the model. And finally, the application is developed in Android Studio. For the methodology of this project, firstly is about CNN model development. It starts with image acquisition from Harvard Dataverse, followed by splitting the database into three sets, which are training sets, validation sets, and test sets. Then the image will go through pre-processing and the CNN algorithm model will be chosen. The model will be trained and validated. If the model accuracy is more than 80% and the loss value is less than 1, it will go through model testing and model evaluation. The model will be compared and the best model will be chosen. Finally, the model will be deployed and converted into TF-like format. After developing the model, next will be Android application development. It starts with installing Android Studio and set up the project. Follow up by importing the TF-line model from the previous flowchart, and the model will be built and run. The application will be debugged and tested on. Finally, if there is no bug left, the apps will transfer to the mobile phone through APK file. The first step of the project is image acquisition. The datasets are obtained from Harvard Dataverse, and the classes are included in the database are healthy, black cigarra, and fusarium wilt. This table shows the dataset ratio and how the dataset is split into training set, validation set, and testing set for each classes. For each classes, the total images are 3,000. and the total images for the whole data set are 9,000. For the data set ratio, there are three different data set ratio, which are 622, 721, and 811. As shown in the table, the data set in training, validation, and testing are vary in each data set ratio. For platforms, the model will be trained, validated, and tested on Jupyter Notebook, and the application will be developed on Android Studio. The CNN algorithms trained are CNN SqueezeNet, which has 40 layers, CNN LSNet, which has 8 layers, and CNN MobileNet, which has 28 layers. First of the training model is image preprocessing. In this instance is image resizing and interpolation. The images will be resized from 480 times 640 to 248 times 248. So this will improve the visualization and focus on specific details, reduce memory usage, and improve computational efficiency. It is performed using a TensorFlow, so it will save as a part of the TensorFlow datasets internally. For this resizing, the image will resize to 128 times 128 pixels for the SqueezeNet and 224 times 224 for the LSNet and MobileNet. Then it will be Android application workflow. It starts with opening the mobile application. It will lead to main page. In the main page, there are two buttons, which are take picture and launch gallery. If take picture button is selected, it will launch the camera. However, if the launch gallery button is selected, it will let the user to choose the image from the gallery. Either side, if the picture is selected, it will detect and classify the disease and display the disease class to the user. Then the user can choose to exit the application or to choose other images to be detected. Now for the result of the project, we will discuss about the training, validation, and testing of the model. First of all is about the dataset ratio and training time. And this slide shows the type of CNN model, dataset ratio, and epoch and time. It shows that the CNN models trained on dataset ratio 622 has the shortest training time. However, it has the worst result because it has the lowest accuracy and highest loss among the others dataset ratio to be trained on. Next is about dataset ratio and performance of SqueezeNet. In this slide, it shows the training accuracy and validation accuracy of the SqueezeNet trained on different dataset ratio. Among the dataset ratio, the SqueezeNet trained on 811 dataset ratio has the best accuracy, which are training accuracy of 90.83% and validation accuracy of 89.78%. For the training loss and validation loss of your SqueezeNet, the best training loss and validation loss of the SqueezeNet are trained on 811 dataset ratio. It has a training loss of 0.24x0 and validation loss of 0.2x71. Besides, we also have the confusion matrix. In these three confusion matrix, it shows that the SqueezeNet that trained on 811 dataset ratio has the best result, as it misclassified the list of the images to the wrong class. Then this slide shows the classification result from the SqueezeNet model. It shows that the QuickNet trained on 811 dataset ratio has the best precision, recall, F1 score, and has an accuracy of 0.88. The next CNN model will be discussed is LSNet. The LSNet that is trained using 811 dataset ratio has the best training accuracy and validation accuracy. It's training accuracy of 98.92% and 90.67% of validation accuracy. Besides, LSNet that trained with 811 dataset ratio has the best training loss and validation loss compared to 622 and 721 dataset ratio. It has training loss of 0.0360 and validation loss of 0.4146. Then the LSNet that trained with 811 has the best confusion matrix compared to 622 dataset ratio and 721 dataset ratio. It has the least misclassification of the classes compared to the others. After that, it's about the classification result of the LSNet model. In this table, it shows that the LSNet model that trained with 811 dataset ratio has the best precision, recall, and F-string score, and it has an accuracy of 0.94. The final CNN model that is trained is the MobileNet algorithm. This slide shows the training accuracy and validation accuracy of the MobileNet. It shows that the MobileNet that trained with 811 dataset ratio has the best training accuracy and best validation accuracy of 95.78% and 94.89% respectively. After that, for the training loss and validation loss of the MobileNet that trained with 811 dataset has the best training loss and validation loss compared to the MobileNet that trained with 622 and 721 dataset. It has the training loss of 0.1167 and validation loss of 0.1484. For the confusion matrix of the MobileNet that trained with 811 dataset ratio has the best confusion matrix compared to 622 and 721 dataset ratio. This is because the model that trained with 811 dataset ratio has the least misclassification compared to the MobileNet that trained with 622 and 721 dataset ratio. Next, this slide shows the classification result of the MobileNet. It shows that the MobileNet that trained with 811 dataset ratio has the best precision, recall, and F1 score compared to the MobileNet that trained with 622 and 721 dataset ratio. It also has the best accuracy among the others, which is 0.95. After analyzing the performance of the models, now we compare the performance between the best models from each algorithm. First of all, we compare the training accuracy and validation accuracy. Among these three algorithms, MobileNet has the best training accuracy and validation accuracy. It has training accuracy of 95.78% and validation accuracy of 94.89%. Besides, MobileNet also has the best training loss and validation loss compared to QuickNet and LSNet. It has training loss of 0.1167 and validation loss of 0.1484, which is lowest compared to QuickNet and LSNet algorithms. For the confusion matrix, MobileNet also has the best confusion matrix. It has least misclassification between the class 2 and class 1 compared to LSNet and QuickNet algorithms. Finally, it's to compare the classification result between the models. And it shows that MobileNet has the best precision recall and reference score compared to SquidNet and LSNet models. Besides, it also has the best accuracy among the models, which is 0.95. After comparing the models, the best model, which is MobileNet, is chosen and implemented in this app, which is called Healthy Banana Leaf. In this app, there are two ways to obtain inputs, which are taking pictures from the camera or launch the gallery to choose the picture in the gallery. On the right side, it shows the UI of the apps. To test the performance of the application is tested with 20 samples of banana leaf images from testing datasets. There are 6 samples of Black Saratoga banana leaf, 7 samples of Fusarium banana leaf, and 7 samples of healthy banana leaf. And the result we obtain, the accuracy in detecting Black Saratoga is 83.33%, for Fusarium wilt is 85.71%, and for healthy is 100%. Hence, overall, the accuracy is around 90%, which is similar to the evaluation of MobileNet accuracy. In conclusion, MobileNet is better at detecting banana leaf disease compared to SquidNet and LSNet CNN algorithm because it has high accuracy rate of 95% and low loss rate of 0.15. Besides, MobileNet that implemented in Android application, Healthy Banana Leaf has successfully detected banana leaf disease. At the end of the project, I have two recommendations for the project. The first is to expand the classes so it can detect more banana leaf disease, and the second one is to provide treatment suggestion. So the application can provide the users with banana leaf disease treatment suggestion. That's all from me. Thank you.